All right, here we go with 7-2, dividing polynomials. There's going to be more rules today, very similar to yesterday. So that's why this chapter is so short, because we do pack a lot of new stuff into it. So here's our first rule we're going to look at today, and it's called quotient of powers. And again, don't worry about that name. We need to get into what we do when we divide. When dividing, you subtract exponents from the same variable. So you remember yesterday, x to the second times x to the third, we added those, right? So today, very similar. When we multiply, we add. When we divide, we subtract. But wait, I have a much better strategy when we come to these. So don't get into your mind we're going to subtract. I have a much better strategy. Let's dig into that. All right, look at the first one I got here. So the strategy you might think, and the book will probably teach it this way, is, hey, since we are dividing, right, this is a divide, we should subtract top to bottom. 5 minus 2 is x to the third, which is fine. But how about when you have x to the second over x to the fifth? Now when you subtract top to bottom, you end up with x to the negative third, which is a problem because we can't have negative exponents, and then we got to fix that. So I have a better strategy. When you have a fraction like this, I like to think of it like this. Which part has more, the top or the bottom? The top does, 5 versus 2. So that's where our variable is going to go, okay? How many more does the top have? Well, what's the difference between 5 and 2? 3. So we're going to put a 3 on that. We're done. That's our answer, x to the third. Now you might say, what's the difference of that than subtracting? Here comes the difference. Look at this one. Which x has more, top or bottom? Bottom does by a lot, right? How many more does the bottom have? Well, what's the difference between 11 and 30? Is that a difference of 19? Yeah. Here's why I like this strategy better. No matter what we have, we're going to end up with positive exponents. We're going to find out later how we're going to need to fix negative exponents. And that's what I'm trying to save you. Up here, what I marked out here, when we got a negative exponent, we weren't done. We were going to have to take another step. If you just look at what we did here, 11 minus 30 would be a negative 19. But since we put that on the bottom of the fraction, it's actually a positive. We've already taken care of the negative. All we need to do is put a 1 on top of our fraction, and that's our answer. Okay, now if we had x to the 30th over x to the 11th, now that's just x to the 19th, which is really x to the 19th on top of the fraction, right? So I hope you can see that. Let's look at this with numbers. Numbers don't change, so treat these like x's. Which 3 has more, top or bottom? Top, that's where it goes. How many more 3's are on top? 3. That's a fine answer. That's a fine answer. Or that's a fine answer because 3 times 3 times 3 is 27. Let's look at this one. All right, first this y needs a 1 on it, right? Okay, take one piece at a time. Which x has more, top or bottom? Top, that's where it goes. How many more are on top compared to the bottom? 3. Which y has more? Top does. That's where the y goes. How many more y's are on top? 3. Done. Not so bad, right? You try. So I want you to try just these first two, and then I'll slide the paper up, and we'll do those. All right, so I'm going to pause it. You try. All right, which x has more, top or bottom? Top does. How many more are on top? 8? 11 minus 3 is 8? Yeah. So you can either just have x to the 8th over 1, or just x to the 8th is fine. All right? Now look at this one, though. Which y has more? The bottom. How many more y's are on the bottom? 4. So we put a positive 4 on the y on the bottom. We don't need to worry about negatives right now, okay? The one thing you need to have, you must have at least a fraction bar, and really you should have a 1 over it to show that it's 1 over y to the 4th. Just y to the 4th wouldn't work, and even if you say, but it's down towards the bottom. Nope, got to have the fraction bar and need a 1. Let's look at this one. Everybody try this one. Which x has more? Bottom. How many more? 2 more. Which y has more? Oh, the y's cancel. The y's are exactly the same. These are great. When we have something like that, cancel them out. We don't need them anymore. All we have left is x to the second on the bottom of a fraction. All right, let's keep moving. Okay, here's another part of this rule. Write this down. When dividing polynomials, treat whole numbers like fractions, all right? And reduce those fractions. So let's look at this first one. Think of -2/14, all right? We need to reduce that fraction. Let me pull my calculator out and show you one more time how to do that with magic in your calculator. If I take that fraction, I turn on my calculator, and I go -2 divided by 14, and I hit enter. I get some crazy decimal. But watch this trick. If I hit the math button right here, math, and then I hit enter twice, down here's the enter button. If I hit that twice, once, twice, it gives me a reduced fraction. Awesome. So really, -2/14 is really -1/7, right? Now let's do our variables. Which y has more? Top. How many more? 2. Done. It's not so bad. Let's look at this one. Everybody try this one. Okay, what is 9/3 as a reduced fraction? Well, I think that's 3/1. You really don't need the 1 down there, but you can have it if you want. Which x has more? Top. How many more? 3 more. Which y has more? Bottom. That's why it goes on the bottom. How many more y's are on the bottom? 3. Now, can we cancel these out because they have the same exponents? No, they're different variables. Done. Good stuff. Hey, this one's going to look really tough. It's not nearly as bad as you might think. I want you to watch this first one right here. And I put the little rule down here. It's not really a rule, it's just advice. First, simplify the inside first, then take everything to the power that's outside. So don't even worry about the power yet. Let's just work on what's inside. So we're going to end up with something inside to the third power. But let's see. Can we reduce 4/3? I don't think so. So that stays 4/3. But what about our x's? Well, how many? It stays on top. That's where there's more. How many more are on top? 2. Look at our y's. Which one has more? Top. How many more? 2. Okay, so this has been simplified. Now we can take everything inside to the third power. And this kind of goes back to what we did yesterday. 4 to the third, whole number to the third. 4 times 4 times 4, 64. We got to take this 3 to the third because it's a whole number. 3 to the third is 3 times 3 times 3. It's 27. But then what do we do with powers to a power? You remember from yesterday? We don't add, we multiply. We have another power to a power. We don't add, we multiply. Now, if you wanted, you could take all this to the third power. I don't know if I would, or I'm sorry, you could take all this and write it 3 times. I don't know if I would recommend that. Let's look at this one. Let's first fix everything inside. So we're going to end up with something to the 4th power. Let's see what we end up with. Well, we've got a 2 there. We don't need to mess with that. Which x has more? Top does, by 1. Which y has more? Whoa, they're the same. They cancel. Excellent. Look how easy this problem has become. We really have just 2x to the 4th power, right? 2 to the 4th power. We actually have to do that work in our calculator. 2 times 2 times 2 times 2. I think 2 times 2 is 4, times 2 is 8, times 2 is 16. And then we have a power to a power. I think we get x to the 4th. All right, good stuff. Let's keep moving on. Let's talk about negative exponents. And this is the big thing to remember. You can fix negative exponents by moving them to the opposite or other side of the fraction bar. So let's look at this example. Just focus on this one right now, not this one down here. All right? Do we have any negative exponents? We do. We've got p to the negative fifth on top. We're going to fix that by moving it to the opposite side of the fraction bar. So it's on top, we're going to put it on the bottom, and that's how it becomes a positive 5. Now, this p to the third, it's not negative, so we don't need to move it. Some people think we just got to flip them all. No, you only move the ones that are negative exponents. So this p to the third is going to stay on the bottom. We don't have anything on top, but there's really a 1 up there. Now, let's simplify. What can we do down here on the bottom? We've got p to the fifth times p to the third. When we multiply, what do we do with exponents? We add them. I think that's our best answer. Fix negative exponents by moving them to the opposite side of the fraction bar. So let's look at this one. This one looks crazy. Oh my gosh, there's all kinds of stuff. Slow down. First step, fix your negatives. So let me ask you, should we move this x to the negative third? Yep. That needs to come downstairs. Should we move this x to the negative second? Yep. That needs to go upstairs to become positive. Should we move this y to the fourth? No, it's already positive. Leave it. Should we move this y to the negative third? Yep. Better move it up. Y to the third moves up. Notice I'm not doing any mental math. Should we move this z to the fifth? No, leave it. It's positive already. Should we move this z to the negative third? Yeah, we better. It's negative. To fix it, we move it to the top. Now you can simplify. Now combine like terms. Now reduce. Let's first look at our x's. Which x has more? Top or bottom? Bottom. By how many? 1. What should we do with this 4 and this 3 of the y's? Should we multiply them or add them? We're multiplying these two things together, so we should add our exponents. Same thing with our z's. What should we do with this 5 and this 3? We should add them up. I don't think we can simplify anymore. I think we got all the x's where they need to be, y's and z's. All right, let's look at the next page. You try this one. So first step, fix your negatives. Then simplify what you can based on the rules that we know. All right, let's fix all negatives. Should we fix x to the third? Nope. Should we fix this x to the negative fourth? Yep. Bring it upstairs. Should we fix this y to the negative third? Yeah. Move it down. Should we fix this y to the negative fourth? Yeah. Move it up. Okay, let's simplify what we can. Look at our x's. They're both on top, multiplying. So what do we do with our exponents? We add them. Look at our y's. We got 1 on top and bottom. Which one has more? Top does. How many more? 1. Or just y. You could have a 1 on there if you want. Can we multiply these up and add the exponents? No, they're different variables. All right, let's keep moving. 0 exponents. These are always real nice. This will go quick. 0 exponents. Anything to the power of 0 equals 1. Sometimes this is so easy, it's tempting to get going too fast. So check this out. X to the 0 power equals 1. Not 1x, just 1. So here's the temptation. It's to say, oh, I see an x to the, or something to the 0 power. That's just 1, right? Hold on. That part is just 1. But that doesn't mean the 2 is just 1. It's not 2 to the 0 power. So we still have that 2 there. But x to the 0 power is just 1. What's 2 times 1? 2. So a lot of times, here's what you can do. If you have 2 times x to the 0 power, 2x to the 0 power, a lot of times, since that's just a 1, we'll just do this. 2. Answer's 2. So that's what I mean. Look at this. This 3 isn't to the 0 power. This y isn't to the 0 power. But this x is. So we can kind of just say, that's an imaginary 1. What do we have left? 3y to the third. Because 3 times 1 times y to the third would be 3y to the third. Hey, look at this. I see a lot of people when this problem's on the test, they do all this work inside. They work. Everything inside here is to the 0 power. So what's the answer? 1. The answer to that whole problem, just 1, because it's all to the 0 power. Okay, now we need to get into some tougher problems. We're going to look at 3 more difficult problems just because they have multiple steps. When you have a fraction, try to do the top first and then the bottom next. Do them separately, see what you have left, and then simplify. Let's just do the top. We're only focusing on the top. I'm going to bring my little thing out here so that we don't look at the bottom. Okay? Power to a power. So what do we have there? A to the 4th, 2 times 2, right? We multiply power to a power. How about the b's? B to the 3rd to the 2nd, we multiply those, that's b to the 6th. Okay, that's our new top. Let's do our bottom. Uh-oh. Everything here is to the negative 2nd power. So here's what I would do. When you have a whole quantity or a whole set of parentheses that's to a negative power, you can move that whole thing to the opposite side of the fraction because it's all going to end up being negatives. So let's fix this by moving it all to the top and fix that negative by turning it positive. Oh, that's tricky. Now there's nothing left on the bottom. Now let's look at this. This is really to the 1st, right? So these aren't going to change. A to the 4th, B to the 6th. But now these are powers to a power. 1 times 2 is 2. 1 times 2 is 2. Let's keep going. Some of these are going to have multiple steps. And now let's combine our like terms. How many total A's do we have? 4 here, 2 here. That's a total of 6. Because when we multiply, we add. How many total B's do we have? 6 and 2, that's a total of 8. Some trickiness in that problem with that negative on the bottom. Let's look at this one. Again, let's just focus on the top. This whole thing is to the negative 3rd power. So how do we fix that? We bring that whole thing to the bottom and it becomes positive. Okay? Now we can fix this. Now we can work on this. What is negative 2 to the 3rd power? Negative 2 times negative 2 times negative 2, I think, is a negative 8. Now let's do our powers to a power. M to the 1st to the 3rd, power to a power, we multiply. N to the 2nd to the 3rd, power to a power, we multiply. So that's the top fixed. What was on the bottom here? Well, I'm going to rewrite it over here so we can see. 4m to the negative 6th, n to the 4th. Okay? Now we've got some choices to make. All right? And really, there's no wrong way. I'm going to write this. Can you see that okay? I'm going to write this down here underneath here. Negative 8 times 4 is negative 32. We can have a negative whole number. We don't need to move that. But look at our m's. You can think of this in one of two ways. We could add up these exponents because we're multiplying, and we could get m to the negative 3rd, right? 3 plus negative 6 is negative 3. And then we could fix that. Or you could have fixed this negative 6 by moving it to the top first. And then which one has more? It doesn't matter which way you do that. Let's look at our n's real quick. N to the 6th and n to the 4th looks like a total of n to the 10th. Still with a 1 on top here. Now we're not done because we still have this darn m to the negative 3rd, which again you could have fixed if you went this way earlier. Doesn't matter. I'm going to move that to the top. So really what we have here is m to the 3rd on top, on the bottom negative 32 n to the 10th. We don't need to fix that negative 32. We can have negative whole numbers. All right, well, tough stuff. One more toughie. These are as tough as you'll see, by the way. Whoa, look at this thing. Now, again, slow down and just do one piece at a time. Once you get started in doing one piece, then another piece, then another, it actually gets pretty easy. Let's just do this parenthesis piece. 3 to the second power. 3 times 3, 9. These are to the first, right? So how many? We take the power to a power, we multiply. Power to a power, we multiply. So that's really what's in the parentheses, right? To the second power. What else do you want to fix in this step? Do you want to go ahead and fix this r to the first by moving it to the top? Sure, I'll put that r to the first there. How about this u to the negative fourth? Can we go ahead and fix that by moving that down? Yeah, u to the positive fourth now. Okay, stay organized. So we've done that. We've done that. We've done that. Do we need to fix either of these? I don't think so. I'm going to put that t to the second here and that u to the seventh here. Okay, so we did just a little bit of each. Now let's do some more simplifying. I think, how many total r's? Now this 9's just going to stay a 9 on top. How many total r's do we have on top? 2 here and 1 here, so we have a total of 3. Okay. What's going to happen with our t's? T to the second and t to the second is a total of no t's. They cancel. That's nice. And how about our u's on the bottom? There's 4 and there's 7, so we have a total of 11. Can we do any more work? I really don't think so. I think we're done. I think we've simplified as much as we can. Hey, I know these 2 days have been a lot of new abstract type learning things, learning some rules, applying those rules. Stick with it. I think we'll review a little bit more tomorrow, and then one more lesson, and then we'll start getting ready to test over this stuff.